Okay, folks, I'd like to start this lesson with a quote from a famous anonymous lumberjack. It says, if x is an exponent, then you'll probably need a log. Okay, well that's hashtag funny, but it's also hashtag true. That is going to be the goal, or one of the key features of all the problems we see in this section. Anytime you see an exponent that has a variable, like x or any other variable name we could use, you're going to need a logarithm to solve that problem. And here are the steps we're going to use in section 6.3 to solve exponential equations and inequalities. There are no new theorems or definitions or procedures in this section. It's really just applications of things we've already learned. So I've decided to kind of show you how to do this just through a series of example problems. The textbook gives us some steps for solving an equation involving exponential functions. Step 1, isolate the exponential function, and step 2 is, if convenient, express both sides with a common base and then set the exponents equal, or take the natural log of both sides of the equation and use the power rule. You could also take the instead of the natural log, you could also take just you could take any log actually, but for whatever reason mathematicians prefer to take the natural log. Perhaps that's the more pure approach. Let's go ahead and start with this first problem. 2 raised to the 3x power equals 16 to the 1 minus x power. Well, the exponential that has a variable is 2 to the 3x. We also have a 16 to the 1 minus x here. So we've already isolated both the variable expressions that have an exponent with that includes a variable. Second thing we'll try to do here is to express both sides with a common base and then equate the exponents. And I think we'll be able to do that with this one because both 2 and 16 are powers of 2. On the left hand side, I'll start by rewriting this as 2 to the 3x. Notice I haven't changed anything. On the right hand side, I'm going to go with 2 to the 4th power raised to the 1 minus x. 2 to the 4th is equal to 16. Now I can multiply these two exponents together. When you raise a power to a power, that's one thing you're allowed to do. So I can rewrite this as 2 to the 3x equals 2 raised to the 4 minus 4x. At this point, we have two different things that are both powers of 2, and they are raised to an exponent. Well, if they're equal, we can set the two exponents equal to each other. So 3x has to equal 4 minus 4x. We'll go ahead and solve for x right now. After just a little bit of algebra, we come up with the solution to this equation, x equals 4/7. Example problem 2. Solve 9 times 3 to the x equals 7 times 2 to the x. As a refresher, I'm going to pull those rules out from the previous slide. And hopefully after a couple examples I won't need to continue showing you those rules. This one, unfortunately, because we have a 3 raised to the x and 7 raised to the 2x power, it is not going to be convenient for us to express both sides with a common base. So I think what we're going to have to do is resort to step 2b, and that is take the natural log of both sides. Taking the natural log of both sides gives me the ln of quantity 9 times 3 to the x equals the ln of 7 raised to the 2x power. Now I'm going to go ahead and use some properties of logarithms to transform this equation so that it looks a little different. I'm going to say that the natural log of 9 plus x times the natural log of 3 equals 2x times the natural log of 7. So I use the multiplication property of logarithms as well as the power rule for exponents. At this point, I have no exponents left in the equation, so I'm going to use just traditional algebra techniques by getting x on one side of the equation. Then I'm probably going to factor out an x and then divide so that x is all by itself. I'm going to go ahead and do that now and then show you the final result. After moving x, all the x terms to the right-hand side of the equation, then factoring out an x, I get the following equation here. Now I'm ready to go ahead and solve for x by dividing both sides of this equation by this term right here, and that'll result in the following. X equals 2 times the ln of 7 minus ln of 3 in my denominator, and the natural log of 9 in my numerator. Now we could simplify this a little further if we really want to. The ln of 9 will stay, and then 2 times the ln of 7 is really the ln of 49 based on the power rule of logarithms, minus the ln of 3. And if I want, I can rewrite the ln of 49 minus ln of 3 as the ln of 49 divided by 3. And that is a completely simplified answer. WebAssign should accept any one of those three forms. Now let's move on to another example. Example 3, solve 16 times 4 raised to the 8x power equals 1/16 times 2 to the x. If we think back to our rules, one of them said, or the procedure for solving exponential equations, one of them said try to state everything into the form of a common base. Well, I see a lot of 16s, and I know that 16 is 4 squared. So what I'm going to try to do is rewrite this as a base 4 equation. That'll give me 4 squared, because that's 16, times 4 raised to the 8x equals 1/16, which is 4 to the negative second. Then raise that to the 2x power. I'm going to use some properties of exponents here and rewrite the left-hand side as 4 to the 2 plus 8x power. Yes, if you multiply two powers that have the same base, you add the exponents. And if I raise a power to a power, I multiply the exponents. So over here I'll have 4 raised to the negative 4x. Since both left and right-hand sides of this equation are in terms of base 4, I can set those two exponents equal. And that'll give me 2 plus 8x equals negative 4x. And I'll go ahead and use a little algebra 1 to solve that. Final answer for this one, x equals negative 1/6. Okay, here's example 4, and I apologize if you're watching this late at night. This one has e in it. That could be scary. Hopefully you're not too frightened and you can persevere through this problem. So we have e to the negative 72k equals 1/5. I hope I don't need to remind you that e is a number. It's not a variable. So we have e raised to the negative 72k equals 1/5. That means we need to try and find out the value of k that makes this equation true. Well, neither of these, neither the left or right hand side can be written in terms of a common base. So I'm going to go ahead and take the natural log of both sides. So I have the natural log of e to the negative 72k, and then I can rewrite as negative 72k times the natural log of e equals, well, the ln 1/5 is 5 to the negative 1 power. So I want to kind of write that over here. The ln of 1/5 is the same as the natural log of 5 to the negative 1 power. So I can rewrite that as negative ln of 5. And if you don't believe me, go ahead and test that out on your calculator. Okay, so now I have an equation here that I have to solve for k, and it's actually going to be pretty easy. This term right here is equal to 1. Think of it as, what exponent do you have to put on the number e to get e? Well, it's 1. So that means k is simply going to be equal to the negative natural log of 5 divided by negative 72, and those two negative signs will cancel each other out. So our final answer is ln of 5 over 72. Alright, I have, this is example problem number 5. I have 10 total that I want to do for you in this section. So I'll break this video into two parts. This will be the last one I do in this part, and then you'll have to check out the award-winning part 2 to see the other 5 examples. First thing I want to do here is, well, I see an 8 on the left and an 8 on the, a factor of, or a multiple of 8 on the right. I'm going to divide both sides by 8. See if that simplifies anything here for me. Now that gives me e cubed equals 4e to the negative 4x. At this point I look to see if I have a common base on the left and the right. Well, I do have base e on both the left and the right, but with that multiplier of 4 on the right hand side, there's not much I can do with that, so I have to resort to taking the natural log of both sides. So that's going to be ln of e cubed equals the ln of 4 times e to the negative 4x. So the right hand side, this is how I want you to think of it. What exponent do we have to put on the number e to get e cubed? Well, there's only one possible number, and that's 3. The right hand side, we have to do a little bit of work. We have to use some properties of logarithms to break this up. So this is going to be the ln of 4 plus the ln of e to the negative 4x. Now the ln of e to the negative 4x, we can take out that exponent using the power rule, and that'll look like this. 3 equals ln of 4 minus 4x times the ln of e. Well, the ln of e is just 1, so we have 3 equals the ln of 4 minus 4x. And now we can use traditional algebra techniques to solve for x. Final answer, x equals the ln of 4 minus 3 all divided by 4.